Hey, Radians here. In today's video, we are going to build a stunning report for an existing time tracking application. This report will feature filters, a table, a pie chart, and a line chart, all created without the use of component libraries. We'll be using React, TypeScript, and CSS to develop reusable components that make it easy to create complex user interfaces with minimal effort. While the Increaser codebase is private, you can find all the reusable components and utilities in the Horizon Kit repository. At Increaser, users can track their time by either starting a focus session or adding a manual entry. Each session is represented as an object with a start and end timestamp along with the project ID. The goal is to transform these sessions into a valuable report that helps users understand how they're spending their time over different periods. For example, users might want to know how much time they're dedicating to their remote job over the last 8 months, whether their work hours are increasing or decreasing, and what steps they can take to enhance their productivity to work less. Or they might be interested in how consistent they are in working on their business project and whether they are investing enough quality time each week to advance it. Storing every session in the database would lead to an overwhelming amount of data. To manage this, Increaser retains only up to 2 months of session data at any given time. At the start of each month and week, the application analyzes all the sessions to calculate the total time spent on each project during the previous period. These totals are then stored in the weeks or months arrays within the respective project's object. If no time has been tracked for a project during a specific period, there will be no update to its array. To represent a week or a month, we use a combination of the year and the week or month number. Currently, Increaser's frontend receives all the user data in one go. Given the modest amount of data and a robust caching mechanism, this approach is feasible. However, we will eventually need to segment the data as the week and months data will accumulate years of information and increase in size. Our report code should not be concerned about the concept of session or the specific method of organizing data at the start of each week and month. Instead, it should receive a record of projects containing only the data necessary for the report. The essential project data includes a unique identifier for the project's color in HSLA format, the name of the project, and arrays of objects representing the total time tracked for the project during specific periods, such as weeks, months, and days. In terms of data handling, we are also introducing a feature that allows the user to hide project names in the report. This enables them to share their workload without revealing the specific projects they're involved in. To accomplish this, we are introducing a top-level context called track time context that will store projects in our desired format and a preference for hiding project names. The mutable state containing the user preference will be maintained in a separate type called track time preference. To keep our context data structure flat, we'll play the preference fields alongside the project's record. Additionally, we'll include a setState function in the context to enable users to update their preference. For an improved user experience, it's advantageous to keep user preferences persistent. For preferences that are not highly critical, we can utilize local storage to store them. If you're interested in learning more about how local storage is used to maintain state across user sessions, be sure to check out my other video on this topic. The track time provider will transform our raw data into organized buckets of days, weeks, and months. To allocate a session's duration to the appropriate bucket, we use the merge track data point utility function. Although using classes to represent week, months, and day objects could simplify comparison and merging operations, I generally avoid this for data coming from the server or being serialized for local storage. This is because of the constant need to convert the data back to class instances. Instead, I prefer using plain objects and utility functions for management. In this scenario, as each group will have a seconds field, we use the entity with seconds type to ensure the accuracy of the data type. To compare two periods, we check if the descriptive fields are equal, such as the year and week fields for a week. To represent a period as a timestamp, we determine the time at which the period started. This can be easily done using dateFNS helpers. Additionally, we'll need to have a function to convert the timestamp back to the period format. The hide project names utility function will assign a unique name to each project based on the order of the project's total time tracked. To iterate over a record and return a new object with the same keys, we use the record map function from the Rising kit. With the track time provider established, we can now access the project data and user preferences within our report components. Next, we need another provider to manage the report's filters and date range. When a user wants to highlight a specific project in the report, it will be reflected in the active project ID field. The time grouping field will determine how the data is grouped in the report, such as by day, week, or month. The include current period field allows user to decide whether to include the current period in the report. Since the current period may not have concluded yet, some users may prefer to exclude it. The time frame field determines how many time groups are displayed in the report. Given that we maintain a limited amount of daily data, the maximum time frame for the day grouping will be 30 days, while for weeks and months it will be null, which means all available data. Similar to the previous provider, we'll keep the user preferences persistent using local storage. However, this time the hook will include additional logic for validating the active project ID. If a project is deleted, the active project ID will be reset to null. In addition to user preferences, the track time report provider will also provide a function to change the preferences and supply the data necessary for the report. Since the project data is already organized in the previous provider, he will maintain an array of the total time tracked for each project based on the selected time grouping. To determine the first and last time groups, we'll use the first time group started at and last time group started at timestamps. Our primary goal in the track time report provider is to construct project's time series, an object that contains the total time tracked for each project based on the selected time grouping. To achieve this, we first need to find the timestamp of the current period using the helper hook use current period started at. Also, it could have been a helper function. We've chosen to keep it as a hook in case we want to be aware of real-time changes to the current period in the future. To determine the timestamp of the previous period, we'll use the subtract period utility function, which subtracts one period from the current period's timestamp. For days and weeks, we use the convert duration utility from Rising kit. However, for months, we'll use the sub-months function from dateFNS due to the variable duration of months. Remember the include current period user preference? Based on this, we will determine the last time group started at. To find the first time group started at, we'll go through all projects to identify the earliest time group. These two timestamps will define the range of the report. To find out the exact number of data points to display, we will calculate the difference between the first time group started at and last time group started at in weeks, days, or months, depending on the selected time grouping. If the time frame is set to null, we'll display all available data points. Otherwise, we'll show the lesser of the time frame and the total data points available. To construct project's time series, we'll go through all projects and create an array of the total time tracked for each project based on the selected time grouping. We'll reverse the array to show the most recent data first. If a data point is missing, we'll default it to 0. To iterate over the record, we'll use the record map function from Rising kit. Finally, we'll validate the time frame preference within the useEffect hook to ensure it's within the available range. If the user changes the time group and the selected time frame is not available in the new group, for instance, if the all time option is unavailable in the days time group, we'll reset it to the first available value. Now that we have established both providers, let's dive into implementing the report itself. The root component of our report will consist of two main sections, a header and a content area. The header will display the report title and filters, allowing users to refine the data displayed. In contrast, the content section will hold the actual report data. To ensure our design is responsive and space efficient on smaller screens, we'll avoid wrapping the content in a panel by using the Based on Screen Read component from RideonKit to adapt our layout to different screen sizes. When it comes to displaying filters on various screen sizes, we need a responsive design approach. For this, we'll use the two components from RideonKit. First, the element size array component helps us to determine the width of the parent element, ensuring our filters fit comfortably. Second, the based on number component is a simple helper that I prefer for its readability, allowing us to make adjustments based on specific numerical conditions. To keep the user informed about the number of actual data points displayed in the report, we'll use the track time report title component. This component will dynamically show the number of data points based on the selected time grouping. And if there is no data available, it will display a message indicating that there are no data points to show. For the time grouping selector and time frame selector, we are utilizing the expandable selector component, which is very convenient for these types of filters. We'll retrieve the user's preference from the track time report context. Then when the user changes their preference, we'll update the context state using the setState function to reflect the new selection. To achieve a consistent look with the include current period selector and other filters, we'll use the select container component from RideonKit, which is a common element in both. To indicate whether the current period is included, we'll display a round check mark that changes color based on the isActive prop. Finally, let's talk about the Manage Projects Name Visibility component. For this, we are combining the icon button and tooltip components from RideonKit. Depending on the selected value, we'll use either the eye icon or eye of icon to visually represent its state. To ensure that this button matches the size of the other filters, we'll use the same dimension CSS utility function with the select container min height value, maintaining consistency across our filter bar. The content of our report consists of three main components: project's distribution breakdown, project's distribution chart, and project's time series chart. However, in order to display the first components, we need to make sure that the user has created projects and has tracked some time within the selected period. To handle this, we'll use the requires projects component, which checks if the project's time series object is empty. If there are no projects or track time, the component will display a message encouraging the user to create projects and track time in order to view the report. Next, we have the requires track time component, which plays a crucial role in ensuring that there is actual data to display. It takes the active time series and checks that at least one data point is greater than 0. If there is no track time for the selected period, the component will kindly inform the user with a message indicating the absence of track time. The active time series could either be the time series of the active project or a combined time series of all projects. To merge these data arrays efficiently, we'll use the merge same size data arrays utility from RideonKit. This ensures that we have a cohesive dataset to work with, regardless of whether we are focusing on a single project or looking at an overview of all projects. Similarly, we need to wrap our time chart component in a component that ensures there are at least 2 points to display a line chart. This is because a line chart requires at least 2 data points to draw a line between. In the project distribution breakdown component, we present a detailed list of projects. For each project, we display its total time tracked during the selected period, the average time tracked per day, week, or month, and the percentage of the total time tracked. At the bottom of the list, we provide a summary that displays the sum of all projects' tracked time, giving the user a clear overview of their time distribution. To maintain a consistent alignment between the header and values, we use the breakdown row content component for each row, which organizes the content into a grid layout. We allocate 8 pixels for the project indicator circle, 120 pixels for the project name, and 92 pixels for each of the remaining columns. The last 3 columns are aligned to the end of the row to ensure a clean and structured layout. As a result, we don't need any additional styling to arrange elements in the header. The only customization we require is changing the text color to text shy. This subtle adjustment ensures that the header is less prominent than the content, maintaining a clear visual hierarchy in our breakdown. Before we start listing the projects, we want to sort them by the total time tracked to provide a meaningful order. To achieve this and to ensure that we have a consistent ordering for the pie chart as well, we'll create a small helper hook called useOrderedTimeSeries. For the share column in our table, it's important to know the total time tracked across all projects. This can be calculated using the useCurrentTime hook, which gives us the aggregate of all the tracked time within the selected time frame. To enhance user interaction, we wrap every row in the interactive row component. This allowed the user to highlight a specific project by clicking on its row, which updates the active project ID in the context state. If the user clicks on the All Projects row, we reset the active project ID to null, indicating that no specific project is highlighted. For formatting durations in our table, we'll use the format duration utility from RiseonKit. And for formatting percentages, we'll rely on the 2% utility, also available in RiseonKit. To draw attention to the numeric portions of values in our table, we employ the emphasize numbers component. This component cleverly splits the string into parts, making the non-numeric sections smaller and thinner, thereby emphasizing the numerical data. Adjacent to the breakdown, we feature a pie chart that provides a visual representation of the distribution of time across projects. We utilize the useOrderedTimeSeries hook again to sort the projects by total time tracked for consistency. We then map the sorted projects to the data structure required by the pie chart, which includes the value and color of each segment. Given that all the relevant information is already displayed in the breakdown, we aim to keep the pie chart straightforward by using its light version called minimalistic pie chart. If you're interested in learning more about its implementation, feel free to check out the corresponding video, which you'll find in the cards and in the description below. The final piece of our report is the project time series chart. Instead of using a single component that handles everything, we rely on a number of smaller chart components. This approach may result in more code, but it allows for greater flexibility. I won't go into detail on every component that makes this chart work, as I have a separate video that explains how to create a line chart from scratch without using any component libraries. The main enhancement to the existing line chart implementation for this report is the ability to display a stacked area chart. The project's line chart component is designed to render a single chart when a specific project is active. However, when no project is selected, it will render multiple charts, one on top of another, to achieve a stacked chart effect. To accomplish this, we need to render the same number of charts at their project, but there's a twist. Each subsequent chart should represent the total time tracked of all projects, minus the time tracked by the projects represented in the chart rendered before it. To calculate this, we iterate over the normalized totals and multiply each data point by its share of the total time tracked during that period. While this may sound complex, a thorough watching of the previously mentioned video on creating a line chart and a review of the code should provide a clear understanding of how it works. To achieve a bit of transparency in parts of the stacked area chart, we first render the chart area with a solid ebb background color, then we make another path with a semi-transparent fill. Additionally, to support a gradient effect which looks even nicer when a single project is selected, we have a fill kind probe that can be either gradient or solid. Our chart can also be displayed as a smooth line by setting the data points connection kind probe to smooth. However, for this report, use a sharp connection between data points to make it clear where the data points are. That's all. If you found this breakdown useful, please like and subscribe.